All right, so number six. Let's I was go back and think about stuff and relook at stuff, especially if I think I might have gotten it wrong. I mean, there's a lot of writing, right? Like there's a lot of writing on page 24 where he's writing about explain the results. That means you have to explain something. It means there's going to be something to explain, right? Like I have to describe something. So if it's totally random, there's not really much to explain. It's random. It is random, or it seems random. 3 words, period. But when he's saying, you know, algebraically equivalent, there's a lot of hints in this question. Number 6, the calculation performed in the chaos program can be written in a number of ways that are algebraically equivalent. Okay, is that going to be? So let's see if A, B, and C are algebraically equivalent. Comes 1 minus x. 3.9x times 1 is 3.9x. 3.9x minus 3.9x squared. Yeah, they are all algebraically equivalent. They are. They're all algebraically equivalent. So again, you want to go back to the mathiness. So A and C is definitely algebraically equivalent because 3.9x, if you distribute 3.9x, right, like if it was algebra, you distribute that to the 1, then you get 3.9x. And then you distribute it to the negative x, and you get, and then the net answer is going to be 3.9x minus 3.9x squared, which is C, right? It's 3.9x minus 3.9 times x times x, right? Then you look at B, it's going to be 3.9. We're going to move the parentheses, x minus x times x. So x minus x times x. So that is if 3.9 is on the outside. So yeah, so if you distribute the x to the 1, it's going to be x minus x squared. So x minus x squared is going to be x minus x times x, right? X minus x squared. So A and B and C are all algebraically equivalent. So then there's a lot of writing here saying write the version of the program for each of the following ways of doing the computation. Have your modified programs print out the 100 iterations of the function, compare the results when you run on the same input. Again, a lot of evidence that it's not just random. Explain the results of this experiment. Hint, see discussion question number 4 above. Okay. Number 4 says modify the chaos program so that it prints out 20 values instead of 10. Okay, so we want to do, so let's start with A. Let's go back to A. So this again goes back to slowing down. So even I'm saying this to myself a lot. So 3.9, yeah, I mean, even though you're confident, you're excited, you're learning something new, you feel like maybe you're learning a secret, or you're learning something that you like, you're excited to learn. It's still important to just patiently plod along. Just be very patient. Go back, double check, triple check. All right, so and then so then we're gonna come here. And we're gonna come here. Actually, we're gonna come here. We're gonna open, and we're gonna go to Python, chaos. Nope, that ain't it. So let's try it again. Let's try to save it. Save it as chaos.py in the Python folder. Save. Replace. Right? It's going to be 3.9 times x times 1 minus x. So this is going to be A. Right? Now we go back here. Now we go to open. Now we go to, let's just go back. We should be good though. If we go to desktop, then all the folders are not big order. Then we go to Python because it's in. Then we go to chaos.py because we just saved it. So we should be good here. Yes, so this is right. So you always want to double check. Okay, good. Range is 100. All right, now we go here. Now we're make sure we're clicked into here. Right, now we can run it. Run module. And then it'll automatically open this shell on here. And then now so now I want to think we're going to run on the same input. So it doesn't matter what we run. It's got to be between 0 and 1. Let's run these next three in this with the same number. So let's just do 0.5. Right? Now let's see if we can do this. I don't want to mess it up, but I like to practice stuff. So let's see if while that's doing, we can click around. And I think we can. I think it's still running. It's just running in the background. Yeah. I think it just, yeah, it ran until it stopped. Yeah. So this is just stuff you learn. You just pick up. You try stuff. You're not going to, you're not going to, spill a bunch of water on your computer on purpose. I mean, that's just ridiculous. But, if you want to try to see if you can do something else while it's running in the background, I mean, just little things you like to try out. Just to, I guess, kind of break stuff. I don't know. So you kind of try different stuff. Okay, so let's do B. Which again, all these are algebraically equivalent. X minus X times X. Save it. And we go here. Actually, we're not going to open that. We're going to go here. Now we're going to go to open. Now we're going to go to chaos. Just saved it. And then we double check. Yes, that's the crucial line here. Let's go back down here. Oh, no. We stay here. We run it. Run module. So, 0 and 1. Now, we're going to do 0.5. Ooh, it looks familiar. So the last one was 0.954629. 954629. 954629. So the first had 3 digits. 0.3 digits. Okay, so it's a little bit different because this is 0.33546. Okay, so a little bit different. Let's try. All right, let's change this up now. Times X minus 3.9 times X times X. Okay, we save it. All right, the dot's gone. We've saved it. Now we're going to go to idle. Click idle. Open both. Make sure we're clicked into here. So click that once or twice. You should see, go to File, Open, chaos.py. It should be good. It should be different. I think that's the same one that we had. Let's X out of that. Let's try it again with that X out. So let's open it. Let's just try different stuff and see sort of how the program works, how your computer works, and that's how it works. So that's what we just learned right now. So if that is open, that window is open, the program, chaos.py, even if it's an old version, if you try to open a new version, at least on this version of Mac and this version of Python, it won't open the new one. Or maybe it's down here. I'm pretty sure it just won't open it. I think it's being blocked. If I just minimize, yeah, it's just being blocked. So, anyways, that's just good to learn and just sort of keep track of that. It's not just learning Python, but you're also like learning about your computer. You're learning about your muscle memory and where things go and folders and bins and proper syntax. I mean, it's being able to get around your computer and being able to solve problems. So okay, so now let's run it again. Run module 0 and 1, 0.5, 0.975 again. So all three started at a 0.975, but it looks like they didn't end with the same number. That's interesting. Yep, it's interesting. So let's sort of look at these. 0.95, 0.33, 0.869, 0.95, 0.33, 0.869, 0.95, 0.33, 0.8. Okay, so the first four, so a bunch of them look the same. Let's get the last few. 3808, 8903, 6473. Nope. So I guess if you want to get really granular, we could just look, where do they break off? And some genius mathematical students. Remember, I was an English guy. So you guys are going to catch this quick. Let's see what I would do. I would, I'm a very rote person and kind of, you know, I would be boring. I would literally like sit down and write down. Let's see, how can we do it where we can see it on the same screen? Okay, I got an idea. We've tried this before, remember? So let's go here because I want to show you guys this and not like. So I would either write it longhand, or I could do a new file here and just print this out. I print out all 100, and then print the other one out, right beside it. So there's a couple ways to do it. All right, so that's that, right? And then, yeah, so how else could we do it? We could delete these, right, because that's the first one. And then we could tab in and see if they come out good or not. If they don't come out right, then we'll delete it, right? We'll just undo. So let's just look how this looks. So we just want to have a method, right? Let's methodically figure out how we're going to solve this. Oh, didn't work. So we're going to undo that. Oh, just learned that. Not good. It like weaved it in. It looks like it weaved it in, or no, I think it just dumped 0.975, and then all of those 100 were like 2 through 101, and then number 2 got pushed down to 102, and then it went on, down. So okay, so that's what we learned. Let's try opening a new one. So let's do a new file, and then let's paste it. Okay. So now this is a little bit easier. Still kind of tough to read. We could have put it in Notepad, but okay. So 975 095 335 442 962 141 475 972 104 363 9202 343 8799 412 940. Oh, it changes. So 412 is 15. Oh, yes. The endings are different. Look at that. And you could kind of see if you're sort of thinking about the numbers, like when you click back, you can feel these numbers, like your eyeballs can feel these numbers change and feel these numbers be the same. If you click back and forth, that's interesting. Yeah, so those are different. Yes, that's what happens. So let's see when these first digits start to change. So number 20 is 0.327. Still 327. Okay, let's go down to 0.33. The 33 is 0.899. 33. 0.899. Okay. Let's go to 47. 884. 884. So the digits start to change. All right, let's go way down to 70. 376. 356. Okay, we're getting closer. Let's go to 51. 714. Boom. All right, let's go to 57. I know there was a thing where you start splitting. The most efficient way to get a number is to keep cutting everything literally in half, right? Which kind of makes sense, right? So we could do 100 and then 50 and then 25. So let's try that. Let's do 100, and then we'll go to 50. 0.241. There it is. Now let's go to 25. Well, actually, we want to go from 50 to 100. So we're actually not. Yeah, we're picking a number. But it's kind of a different what we're doing is a teeny bit. Yeah. So we're picking the numbers when they change. So let's do 714 is 51. 714 is 51. So let's see. Let's go to 75. Let's go to 75. Yeah, that's how we're gonna do it. 0.862. 75. 0.862. Oop, it's different. Okay. So now we know it's going to be between 50 and 75. So let's split that in half. So 50 and 75 is going to be 12 and a half. So let's do 62. 62. 0.201. 0.201. Okay. Now it's going to be above 62 and 50. So between 50 and 62. So let's go to 56. 56.864. 56.864. Okay, now it's between 56 and 62. 62 is where they're different. So let's go to 59.120. 0.120. So it's between 59 and 62. Okay, so let's just check these out. 412-945-201. Oh, they're all the same. I must have messed this up. Okay, I'm definitely not perfect. So let's all right, I guess I messed this up. All right, so let's look. 63, 627. There it is. That's where it changes. 63. I knew I was close. But it's okay. But yeah, kind of fumbling around in the dark. I figured it out at 63. Between number 1 and number 2. Let's see about number 3. Let's see about the third run. So let's run this one. Just run this down like this. Copy. And we're going to new file. Paste it. Let's look at 63. 627. 627. It's different. 626. 627. Okay, let's look at 911314. 911313. So here's where it changes. 65 changes. 313 when it's really 314 over here. Right? 314 and change over here. So they start to change. Right around 62, 65, in that range, where the third digit starts to be different, and then they start to change all the way down until 100 when they're different. Let's see how different they are by the end. Very different. 0.501, 0.974. 0.339, 0.874. Yeah, very different. 0.71779. Yep, they change a lot. So from about 62 to 65, they change. That third digit changes. That's what I would explain if I had to, speak. And some of you guys can get even more granular, can get even more mathy. You can point out exactly like this changes here, and that's what I would recommend. If that's your assignment, then that's what I recommend. But for this, it just essentially states to modify it. Actually, excuse me. It essentially states to explain the results of this experiment. It doesn't say to write a paragraph. It's just explain it. So I'm just explaining it out loud. Imagining if we got this assigned in class where I got to explain this out loud. And hopefully you get a decent grade. All right, next, the last one for chapter 1 is number 7, the next video. Thanks a lot.